modules 14 through 15, let's remember that we have this quick reference sheet to use at our disposal. And let's take a look at the problem we are going to work on right now. We've got cans of LaCroix are supposed to contain 35 milliliters. And that's just a fact right now that the company wants. There is some variation for each can because the filling machinery is not perfectly precise. An inspector measures the contents in milliliters of 12 randomly selected cans from a single day's production. So that 12 are the randomly selected cans, and I'm guessing, or not guessing, they said the inspector is going to measure the contents in milliliters. So that's our variable, the content in milliliters. And that to me looks like a numerical variable. And that 12 is going to be our number of observations, and that's going to be lowercase n since it's from a sample. And then it's very nice. They give us a dot plot for all the values. So even though they gave you this information over here with X bar and S, and those should both be milliliters, right? Even though they give that to you already, you could punch in these values into StatCrunch and find that X bar and S as well, just by punching in 349 so 349 once, 351 would be in there twice, and I might show you later how to do that. But let's get to some work here. Our step 1 in our hypothesis testing. So I'm just going to zoom in a little bit here. Oh, before I do that, we've also got the significance level here. We were told alpha. And then the most important part when it comes to hypothesis testing, what are you testing? What's the claim that you're testing? In this case, they want us to test at that significance level that the mean amount of LaCroix in all the cans filled that day is less than the target value of 35. So we're looking at mu is what we're testing for. So again, on our reference sheet here, we know that we're going to be in this middle column. In the middle column here, we're not going to look over at P's or Q's or sigmas. We're going to look all at our mu's, our X bars, and our S's and our N's. That's what we're going to have going for us. So we're going to follow this middle column here. And then, it's going back to our problem. So then step 1 of our 4-step method is to always just state the problem. And you'll see I've already got my paper split into 4 quadrants because I knew I was going to use the 4-step method. So I'm going to zoom in over here, and this will be step 1. And step 1 is the step that I call the state your problem. And so in this problem, you're going to state all your info, and you definitely want to use your proper notation. Okay, so you want to be able to call things exactly what you want to call them. I think I'm going to go a little bit smaller here. And then, so we've already been told that N was 12 cans of LaCroix. And we were told that X bar was 352.9 milliliters. I believe that was given to us right over here, 352.9 milliliters. And we were also told that S was, my sample standard deviation was 2.19 milliliters. And then we saw that alpha was 0.01. So a really small significance level here. So this has got to be really weird in order to violate the null hypothesis here. So again, now translating this last sentence here, the mean amount of LaCroix filled that day is less than 355. So I'm going to write that statement. I'm going to give myself a little room so I have time to think. So the mean is less than 355 milliliters. And now I have to ask myself, is that going to be the null or the alternative hypothesis? And because we do not have an equal sign in here, that we just have a less than, strictly less than, that means that this is going to be my alternative hypothesis. And I'm going to put an asterisk there because that's what I want to come back to when I'm making my final conclusion. This is the claim that I definitely want to address because this was the question they asked. And so now I need my null hypothesis. So my null hypothesis is going to be simply the null has to have equality. So I'm going to have 355 milliliters equal to mu there. Some other things that are very important to note here, in this case, we've got a left-tailed test, right? That's good to know the direction of the test. It's going to be all of my alpha and all of my p-value is going to go on the left-hand side. And then we've also want to note in this case something we don't know. Notice that sigma is unknown. All we know is the sample standard deviation. We don't know the population standard deviation. So with that information, we are going to be ready to move on to step 2.